Hey everybody, this is the last of the proof sections. Section 5.5 we're actually going to skip and we're going to go straight into 6.1. So if you made it this far, you know that you're almost done with your proofs. Well, at least for the time being. I think chapter 7 has some. But anyway, so yeah, well basically 5.3 we did the double angle formulas, and now we're going to do the half angle formulas. So in 5.3, we went from equations that had theta and equations that went from 2 theta to theta. Actually, I'll just do back and forth. And this is kind of the same thing, except now it's going to be between theta and theta over 2. So we're halving it instead of doubling it. But overall, it's just manipulations of equations that we did in 5.3. Anyway, let's go ahead and do this. My cat just slid right on top of my paper. Give it back. I'm sorry. Now he's looking at me all grumpy. Okay, so the first one is sine. So it's sine of a over 2. Okay, so the formula is, and it looks nasty, but I'm going to go ahead and prove all of them to show you. It's plus or minus. Now the plus or minus depends on the quadrant. Okay, but anyway, it's plus or minus, and then 1 minus cosine a over 2. Whereas cosine is pretty much the same thing, except it's 1 plus cosine of a over 2. And this is, again, a over 2. Tangent, a over 2. Now, tangent is just made from dividing the 2. And when you divide the 2, the square roots cancel, and you get a pretty nice answer. You either get 1 minus cosine of a over sine of a, or you get, I'll just put another equal sign, sine a over 1 plus cosine a. And I'm going to show you how we do that. So for tangent, you have your option. For sine and cosine, there's just one equation for each. And again, the plus or minus depends on the quadrant. So anyway, let me go ahead and prove these real quick. In 5.3, we prove this is a proven equality. So what I mean by a proven equality is that I can now work on both sides because these two things are equal. So it's not a proof. I can work on both sides. Why? Because we already know they're equal. Anyway, so what we do is we just subtract the 1. And you have negative 2 sine squared x is equal to cosine of 2x minus 1. Then I divide by negative 2. So I have sine squared of x is equal to, and now what I'm going to do is I want that negative to cancel. So I'm going to take a negative out of the top. It seems kind of silly, but I'll show you what I mean in a bit. So this allows the negatives to cancel. Okay. Moving up here. So now I have sine squared of x is equal to, and now I'm going to switch the order. Instead of negative cosine 2x plus 1, I'm going to write 1 minus cosine 2x. And then we just take the square root. And since sine can be positive or negative, we're going to have both solutions. So sine x is equal to plus or minus, I almost forgot my over 2. Okay, so I have sine of x is equal to plus or minus the square root of 1 minus cosine of 2x over 2. Now the last thing you do in order to make it look like the formula, notice that we have x and 2x. So all I'm going to do is say let, what was the formula? Oh, okay. So let 2x, let me write it this way. Let a equal 2x. I'm creating a new variable. So if a is 2x, then that means that a over 2 is equal to x. And all I do is I substitute. Okay? So if this is the 2x, that becomes an a. Therefore, the x becomes a over 2. And you have your formula. Hold on. Fighting with my computer. Let me pause it real quick while I figure out why it's doing that. Alright, so it turns out the Wacom driver stopped working, so my pen stopped working. So I restarted the computer, and hopefully it'll let me stitch the videos together. But anyway, so rewriting this, we have sine of a over 2, basically the formula, equals plus or minus the square root of 1 minus cosine a over 2. And there you go. So it's just getting a 5.3 formula and just rewriting it. Same thing for this one. We have a proven equality, so I pretty much do the exact same thing. Add 1 to each side. So 2 cosine squared x is equal to, I'm going to put the 1 first because that's what the formula looks like. And divide by 2. And there you go. That's pretty much it. We have cosine squared x equals 1 plus cosine of 2x over 2. Then I take the square root of each side. So cosine of x is equal to plus or minus the square root of 1 plus cosine of 2x over 2. And then all you got to do now is do the variable swap. So we get cosine of a over 2 is equal to plus or minus 1 plus cosine of 2a, or 1 plus cosine of a over 2. All right, so there's that formula. And again, when you do your square root, I kind of lazily wrote it. The square root goes over the entire thing, numerator and denominator. Okay, so that's 2 of them proven. The last one is just dividing the 2. There's other ways to do it. You can use another formula for tangent, but I'm just going to divide the 2. So this ends up being plus or minus the square root of, and so here we have, there it is, 1 minus cosine a over 2, all divided by plus or minus 1 plus cosine of a over 2. Now, whenever you're dealing with multiplication and division, we can combine this into one larger square root. And from here, notice if I multiply by 2 over 2, that's legal, and it cancels those 2's out. So we end up with plus or minus 1 minus cosine of a over 1 plus cosine of a. And so there's a formula. And the different answers you get depend on which conjugate you do. So if I do the conjugate of 1 plus cosine of a over 1 plus cosine of a, So basically, if I get the conjugate of the numerator, then I'm going to get one answer. However, if I do the conjugate of the denominator, erase the wrong one, and put a minus in between, which means I did the conjugate of the denominator, I'll get the other answer. So it doesn't matter which. I guess I'll stick with this one, the conjugate of the denominator. And this is inside the square root. And so we have plus or minus the square root of, on the top, it's the same thing twice. So it's 1 minus cosine of A squared. On the bottom, I end up with 1 minus cosine squared of A. Okay, but now we know that 1 minus cosine squared of A is sine squared. Sorry, cosine A squared is sine squared A. And then again, I have a square over a square, or you can think of the square root canceling both out, but I'll go ahead and combine them first. So if you have a square over a square, you can combine them. And that's where the square and the square root cancel each other out. And you're left with just 1 minus cosine of A over sine of A. Now, I looked into what happens to the plus or minus, because the plus or minus does go away. And basically, because that bugged me a little bit, basically 1 minus cosine A, okay, is always positive. Okay, so if you get that term, the smallest cosine can be is 1. Sorry, the largest cosine can be is 1. So 1 minus 1 is the largest it can be. So this 1 minus 1 would give you 0. So the answer for this ranges between 0 and 2. So it's always going to be a positive. Anyway, so the article that I read said, okay, since that's always positive, the sign depends on whatever sine of A is. So if sine of A is positive, it's positive. If sine of A is negative, it's negative. And so that was their justification for getting rid of the plus or minus. But anyway, if you want, I can show you, email me, and I can show you another proof where the plus or minus isn't an issue. But anyway, that's the tangent. And so I proved this one. The other formula can just as easily be gotten if I multiplied 1 plus cosine A instead. And that's how you get the other formula. But I won't bore you with that. So anyway, let's go ahead and do some problems. Find the exact value of cosine 75. So here we're doing the half angle formula. So that means this is already half. So 75 is the same thing as cosine of, and my brain is turned off right now, so I'm going to shamelessly use my notes. 150 over 2. So the 150 is the value that I'm going to use in the formula. So the formula is cosine of 75. And if I look at my notes here, there's two angles we're looking at. So 75 is more like this. Okay, so there's 75 degrees, and then we have 150 degrees, which is the whole thing. All right, so the angle itself is in quadrant 1. 75 is quadrant 1. So look at my sign is going to be a positive. And so it's going to be 1 plus, just using the formula, cosine of 150 over 2. Now, cosine of 150 is over here. And again, I always forget this, so just in the sake of tradition, I'm going to write this out. So here we have 0, can't get off my computer, 30, 45, 60, and 90. So the answers for sine would be 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And we reverse those for cosine. Okay, so cosine of 150 is over here in quadrant 2. And so in quadrant 2, cosine is negative. So plus 1. So this is the same as saying plus negative. You know what? I'm just going to go ahead and write the answer. Cosine is negative. The angle, the reference angle, is 30 degrees. And so I'm going to look up cosine of 30. But since it's negative, I'm going to put it in quadrant. I would just reverse my words there. Since the reference angle is 30, I'm going to look up cosine of 30. And since it's in quadrant 2, I'm going to make it negative. So this becomes 1 minus square root of 3 over 2 over 2. And remember, the whole thing is inside the square root. So all you got to do now is simplify this. What I'm going to do is I'm going to rewrite the 1 as 2 over 2. And so we end up with 2 minus square root of 3 over 2 over 2. Now this is just, I can do times 1/2 times 1/2. There's lots of ways to cancel, so however you want to cancel was fine. But notice that the 2 and the 2 multiply to give me 4. So I have 2 minus square root of 3 over 4, but then the square root of 4 is 2. So now I can split the square root up between the top and the bottom. On the top, I have 2 minus square root of 3, and on the bottom, I just have 2. And there you go. So notice it looks really nasty, but that's what they want as their answer. And I can go to Decimos, and I can show you cosine of 75. Okay, so cosine of 75, and let me make sure that we are in degrees. So cosine of 75 is 0.28819 blah blah blah. And if I type in what I just did, square root of, I already forgot it. Nope. 2 minus square root of 3, and then that whole thing over 2. Notice that we get the exact same answer. And in 5.3, we used the double angle formula, and we got a similar answer. And I believe it was square root of 6 minus square root of 2 over 2. Fiddle with it. It was one of those. Maybe that was the 2 and that was the 6. Maybe this was the 6 and this was the 3. I'll have to fiddle with it. Actually, I can just look it up. All right. Oh, there it is. So in 5.3, we did a very similar problem. And notice that we did it with, it was one of the very first ones we did, I guess not. Double angle formulas. 5.2. There it is. So we did the same thing, and we got square root of 6 minus square root of 2 over 4. This is in 5.2. And it's the same answer. It's different ways to come up with the same answer. So my apologies for getting long-winded there. I was on a mission. So if you go to Desmos, that's awesome. My cat just knocked everything off my table. Square root of 6 minus square root of 2 over 4. So both of these answers, this one was found using one formula in 6.2, and this one was found using the half angle formula. Anyway, let's finish this up. So next says, find the exact value of tangent of 105. Okay, so since we're using the half angle formula, first, 105 is in quadrant 2. Okay, and in that one, tangent is negative. But luckily, the tangent formula doesn't have plus or minus. So anyway, it just kind of fixes itself. So this is the same thing as tangent of 210 over 2. And the formula for tangent, you have two formulas to choose from, and it's honestly up to you which one you want. You can do 1 minus cosine A over sine A, or sine A over 1 plus cosine A. I'm going to pick with the one with the stuff in the numerator, 1 minus cosine A, so that way I don't have to deal with my denominator. It's just one number. So my A in question is 210. So I have 1 minus cosine of 210 over sine of 210. Okay, and the sign for tangent will fix itself if you just work it out. So 210 is going to be a full 180 plus 30 more. And we're in quadrant 3. Okay, and in quadrant 3, both sine and cosine are negative. So cosine of 210 is just going to be negative cosine of 30. So that's negative square root of 3 over 2. And sine of 210 is the same as negative sine of 30, so negative 1/2. So we go ahead and work it out. 1 plus square root of 3 over 2 over negative 1/2. I do exactly what I did last time. I make the 1 2 over 2. And so we end up with 2 plus square root of 3 over 2 divided by negative 1/2. Just like before, the 2's cancel because you're multiplying by 2 over 2. And notice that there's going to be a negative out front. So my answer becomes negative parentheses 2 plus square root of 3, or negative 2 minus square root of 3. All right, so getting the exact answer can be kind of but that's kind of what they want you to do. Keep in mind that if there was a plus or minus, so when you're dealing with sine or cosine, the formulas have plus or minuses in front of them, and that depends on whatever quadrant A over 2 is in. Okay. However, when you're doing the problem, this cosine could be in a different quadrant. Or I'll just put A and A over 2. So you got to be careful. Okay, so for the cosine A, you just follow the formula. If it's negative, then negative. If it's positive, then it's positive. But the formula on the outside will be whatever the original one was, the A over 2. Get off my table. Stop it. All right. So now we're going to do two of these. So if cosine of A is 3/5 with A in quadrant 4, find, and then they say find sine, cosine, and tangent. So here, let's figure stuff out. If A is in quadrant 4, that's going to be, quadrant 4 is 270 degrees all the way to 360 degrees. Okay, if you divide that, if you multiply that by a half, then you get 270 times half. Let me go ahead and get the calculator because I left my calculator in the other room. Okay, and my brain is just completely off right now. 270 over 2 is 135. So that means that A over 2 is going to be from 135, and half of 360 is 180. And all of this is in quadrant 2. Okay, so A is in quadrant 4, whereas A over 2 is in quadrant 2. So anyway, whenever they give us a problem like this, we create our triangle. And this is quadrant 4. And cosine is adjacent over hypotenuse. So this is going to be a 3, 4, 5 triangle. And now we can go ahead and work it out. So I know that sine of A is 4/5, negative 4/5, sorry. I made a big boo-boo there. We're in quadrant 4, so that's negative 4. So sine of A is negative 4/5. Cosine of A is 3/5. And that's all we need. So now I can find all my formulas. So sine of A over 2 and remember A over 2 is in quadrant 2. So it's kind of confusing having to think of two different quadrants. The sine A and cosine A are based off quadrant 4. However, my answer, A over 2, is in quadrant 2. And in that realm, sine is positive. So it's going to be the positive version. But when I plug in my numbers, I'm going to use the numbers that I got here. Okay, so it's going to be 1 minus cosine of A. So 1 minus 3/5 over 2. And that's really all you got to do. Now you can just type that in your calculator if you want. I'm not trying to be an algebra Nazi. So you can say 1 minus 3/5 and then divide that by 2. And then math frac that. And you get 1/5. So you get the square root of 1/5. Well, that's the same as the square root of 1 over the square root of 5, which is the same as 1 over square root of 5. And then you can rationalize the denominator. So you end up with square root of 5 over 5. Okay, you don't have to do that many steps when you're doing this, but I just wanted to show it completely worked out. Okay, so that's sine of A over 2. Now we go over to cosine of A over 2. And that's pretty much the same thing. Now, again, we're in quadrant 2. And in quadrant 2, cosine is negative. And so it's going to be 1 plus cosine of A over 2. And so that's negative. And then again, you can just type it in your calculator because it's very similar. You can actually just press second, enter twice. and change the minus sign to a plus sign. And then notice that's going to be 4/5. So you end up with the square root of 4/5, which is negative square root of 4 over square root of 5, which is negative 2 over square root of 5, and then you can rationalize your denominator. And that gives you negative 2 square root of 5 over 5. So that's sine of a over 2, cosine of a over 2, and now tangent, I'm just going to divide the two. Instead of using a formula, there's really no point if you've already figured out sine and cosine. So you have square root of 5 over 5 divided by negative 2 square root of 5 over 5. And notice if you look at these as a whole, they cancel out. And you're left with 1 over negative 2, or negative 1/2. There you go. Okay, now the thing with these formulas, tangent, if you were doing the formula for tangent, it's the only one that has sine. The formula for sine and cosine just have cosine of a in it. But anyway, so that's going to be a traditional problem from this section. You make your triangle, and you have to keep in mind the sine and cosine are from, the initial angle given, whereas the sign in front of the square root is the sign from whatever a over 2 is. So let's do one more. And there's actually a typo in this one. I got a little carried away. This should say 180 to 270. My bad. So if sine A is negative 12/13, so here if A is between 180 and 270, if I divide everything by 2, then this becomes, again, 90, a over 2. And for the life of me, I cannot remember 135. Okay. So a over 2, 90 to 135, that's quadrant 2. Quadrant 2 is going to be a popular quadrant in this section. Whereas the original problem, 180 to 270, that's quadrant 3. Okay, so A is in quadrant 2. Sorry, A is in quadrant 3. A over 2 is in quadrant 2. All right, so let's go ahead and make our stuff. So sine of A is negative 12 over 13 in quadrant 3. So here is theta. Sine is opposite over hypotenuse. This is a 5, 12, 13 triangle. So this is going to be negative 5. Okay, they say find all 6 trig functions. So let me find sine of A. And I guess I could put theta there, but that should technically be A. Okay, so sine of A is equal to, negative 12 over 13, because they gave it to me. Whereas cosine of A is negative 5 over 13. And those are the only two you need, because that's all the formulas ask for. So now I can figure out sine of A over 2. Okay, now A over 2 is in quadrant 2. And in quadrant 2, sine is positive. So I have 1 minus, the formula for sine is 1 minus cosine A. So 1 minus negative 5 over 13 over 2. And if you'd like, you can use your calculator. So that's a double negative, so that's 1 plus 5/13 over 2. And then you can just math 1 that. So that gives me 9/13, which is 3 over square root of 13. And then you can rationalize that to get 3 square root of 13 over 13. Okay, so that's sine of a over 2. Now we go to cosine of a over 2. And in cosine, we're in quadrant 2, so that's going to be negative. And it's the same formula, except that instead of a minus, it's a plus. And so if you go to your calculator, you can type in 1 minus 5 over 13 divided by 2. And then you can math 1 that. So I get negative square root of 4 over 13, which is negative 2 over square root of 13, which you can rationalize to be negative 2 square root of 13 over 13. Right, so that's sine and cosine. Now from those, we can get secant and cosecant. Let me shrink these because they're taking up too much room. Now for secant and cosecant, I'm going to use the formula I had right before I rationalized it, because that'll make life a lot easier. So for this one, sine, so that means cosecant of a over 2. I'm just going to use, I don't know why I put the arrow there. I'm going to use the flipped version of this one. And so cosecant would be square root of 13 over 3. Same thing. I'm going to use the flipped version. And so my secant of a over 2 is going to be negative square root of 13 over 2. And then the last one we have is tangent. And for tangent, you can again do sine over cosine. Now for sake of using the formula, I'm going to go ahead and use a formula. Now in quadrant 2, for the tangent formula, there's no plus or minus that you have to memorize because the signs will fix itself. So you can use whichever formula you want. I'm going to use the one with one denominator because for me that's just less painful. 1 minus cosine of a over sine a. And so we have 1 minus negative 5/13 over negative 12/13. And if you want, you can use your calculator, but it's actually not too hard to do by hand. But to save time, and I don't want to confuse y'all with a bunch of algebra when we're doing a trig class, that's what we've got to focus on. All right. So notice you get negative 3/2, which means cotangent would be negative 2/3. And notice we're in quadrant 2, and tangent's negative in quadrant 2, so the signs fix itself. All right, there you go. There's your 6 answers for all 6 trig functions. All right, I know that's not fun, but this is the ugliest section in terms of algebra. You're going to see square roots with bleh inside the square root, and yeah. Luckily on the test, there won't be many problems. And in real life, you don't use these as often as you use the formulas in 5.1, 2, and 3. All right, so try page 4 on your own. And so now I want to do these 3 proofs, and that'll be it. We'll be done. So, proofs So this says, prove that sine squared of x over 2 is equal to, and then they give you this formula. So I'm going to pick the more complicated side. Okay, and I already know, on the side of my head, I already know the formula for sine squared. Sine squared of x over 2 is just going to be the formula when you square root it. So plus or minus the square root of 1 minus cosine x over 2. But remember, we're squaring it. And so this is just 1 minus cosine x over 2. So the idea here is if I can get this formula, then I'm done. This formula is going to be the same thing as sine squared. So that's going to be my goal. Okay, cat's going crazy. All right, so let's try it. I have tangent of x minus sine of x over 2 tangent of x. All right, so one thing I can do is I see these tangents, and it's always a good starting point. Just turn everything into sines and cosines. Tangent is sine x over cosine x minus sine x, whereas the bottom one is 2 sine x over cosine x. And so that's what your tangents became. Now this is really over 1. And so now all we got to do is get a common denominator. So here's cosine x, cosine x. So now the denominators are the same. Basically, we can't subtract unless we have the same denominator. And 1 times cosine x is the same denominator. Okay. So I have sine x minus sine x cosine x over cosine x. And then that whole thing divided by 2 times sine x over cosine x. So, looks real scary. But remember, I can multiply the top and bottom by anything that I want as long as it's the same thing. So I'm going to multiply it by cosine x. I'm going to multiply it by cosine x. Same thing on the top and bottom. So that kills those cosines. And notice my formula simplifies quite a bit. Now I can factor out the sine x because it's a sine in both terms. Remember, this is 1 times sine x. So I have sine x, 1 minus cosine x over 2 sine x. The sines cancel. And then I have what I'm looking for. 1 minus cosine of x over 2. And I know that that's the same thing as sine squared of a over 2 because of the formula that I had up here. So anyway, let me shrink it up and make it nice and neat. But yeah, that's your proof. Let me undo that. Let me get a better grab. Okay, so make it look nice and tidy. And there you go. So we started it out, we turned everything into sines and cosines, and I know it gets kind of ugly with your fraction over fraction, but the idea here is that you multiply, if you notice that both fractions on the top and bottom have the same denominator, and they're the only fractions present, you can cancel. Anyway, once we have the 1 minus cosine x over 2, you know that that's equal to my formula, sine squared of a over 2. So let's do the other one. So I have tangent of b over 2 equals secant b, secant cosecant b plus cosecant b. All right, so I'm going to do the exact same thing that I did earlier. Again, we are going to get fractions over fractions. Be not afraid of the fractions over fractions. So secant is 1 over cosine of b. Secant 1 over cosine of b times cosecant 1 over sine of b plus cosecant 1 over cosine of b. Okay, so what I can do here is I can just do what I did earlier, multiply everything by cosine b over cosine b. And what happens is the cosines cancel. Well, let me go ahead and write it out. Remember, this is cosine over 1, cosine over 1. So if you were to distribute, you're going to get a lot of stuff where cosines cancel. Okay, so you multiply everything by cosine, and you end up with cosine over cosine is 1. Here the cosines cancel, so those cancel, and that's a 1. Those cancel, that's a 1. 1. Here they just cancel, and you're left with 1 over sine b plus 1. Okay, almost done. So now, I'm trying to think, how does that help us out? So this one, hold on, I'm having a brain fart right here, right now. Such is my life. All right, I'm going to start this problem from the beginning just because I screwed up. Not screwed up, but this guy here was supposed to be a sine, and that just, rather than try to fix it in all the places, I'm just going to go ahead and just start over. Gilbert screwed up. All right. So starting over again, we have 1 over cosine of b all over. Secant is 1 over cosine of b. Cosecant is 1 over sine of b plus, and then that's cosecant, not secant. So that's going to be 1 over sine of b. Okay, so now they don't all have cosine in common, so I can't do what I did earlier. But what I do notice is I can try to get the same thing going on here. Notice on the bottom they have cosine b sine b. So all I'm missing is the cosine b over here. This is a different approach. And so when I do that, now they have the same denominator. And if they have the same denominator, you can add them up. So I have 1 plus cosine of b over cosine of b sine of b. Okay, now it's looking like something we like. Now I can multiply by cosine over cosine. And what that does is cosine b cancel out. Cosine b cancel out. And you're left with 1. So on the top, Remember, I'm just dealing with these two. On the top, the cosines cancel. And on the bottom, all that happens is the cosine that I added cancels with the cosine that was in the denominator. So now we have 1 plus cosine over sine b. And then the last thing you do is multiply by sine b over sine b. Those cancel. And you're left with the formula. Sine b over 1 plus cosine b. And that's the same formula as tangent, b over 2. All right, so I apologize for screwing up. But yeah, these proofs are going to have a lot of fractions within fractions. So they may get a little bit frustrating. But as with all math things, the more you do it, the more you kind of get used to manipulating all the variables. All right, last one. Cosine to the fourth theta equals. Now, I picked this one because I liked it. Good stuff. We're going to start with a more complicated side. And I'm going to get it to where they all have the same denominator. So I have 1/4 plus cosine of 2 theta over 2. I'm going to multiply that by 2 over 2 because I want that to have the same denominator. Okay, so this ends up with 1/4 plus 2 cosine of 2 theta over 4 plus cosine squared of 2 theta over 4. Notice I can factor a 1/4 out. All right. So this looks kind of weird, but this is where we do a thing called variable substitution, which is why I picked this problem. If you recognize it, then you can go straight to the answer. But if you don't recognize it, notice that I can say let u, it can really be any variable, it doesn't have to be u, equal to 2 theta. So if you, let u not just 2 theta, if you let u equal cosine of 2 theta. So if that happens, that means I can replace all of my cosine of 2 thetas with a u. And the only reason we're doing that is to make it easier to look at. Notice that this is just a formula I'm used to seeing. This is u squared plus 2u plus 1. That's just u plus 1 squared. So I can replace it with what it actually equals. And so now we have u is, so I have cosine of 2 theta, because that's what u is, plus 1 squared over 4. Let me shrink everything again. I don't like this section. It's the nastiest of the 4 sections we've done just because of all the fractions involved. But anyway, so we end up with this, but notice that 2 is just, 4 is just 2 squared. So I have the same thing squared, so I can kind of go backwards, and I can say that this is cosine of 2 theta plus 1, parentheses in the wrong spot, over 2 squared. And then that is the formula for sine squared. Sorry, cosine squared. But the squared is still there, and so you end up with cosine of the fourth. So that's the proof. And I apologize for kind of running out of room there, but yeah, I like it. The main thing is you don't have to do the u substitution. You can essentially go straight from this step to this step if you want. I just didn't want to confuse everyone with how did he get that. It's just 1 plus 2 something plus something squared is the formula for a perfect square, which is u plus 1 squared. But the u is cosine of 2 theta, so plus 1 squared. And then we just kind of do some more manipulation to get the cosine of the fourth. Anyway, I'll stop the video here. Sorry, I know I wasn't on my A game tonight, but I hope you all have a good day. And yeah, almost done. I'm just rambling.